Before we can even begin to understand the brain's incredible electrical signals, we first have to solve a geometry problem. A really precise one, right on the human head. It's a hunt for one single critical point. And believe me, this is where it all begins.
So, you might be thinking, placing a few sensors on a head, how hard can that be, right? Just kind of get them in the general area? Well, that leads me to this really important question. Why is close enough not just a little bit wrong, but actually dangerous when it comes to reading the brain? The answer? Well, it changes everything.
Just look at the difference here. On the left, you've got guesswork. It's pure chaos. You get asymmetry, you start seeing false patterns that aren't really there, and you miss crucial features. But on the right, that's what you get with measurement. Your results are reproducible, they're comparable to other studies, and they're scientifically defensible. It's the difference between hearing static and hearing the actual music.
And this brings us to the absolute, non-negotiable golden rule of EEG. I really want you to let this sink in. If your starting points, your landmarks, are wrong, then every single electrode you place after that will also be wrong. There's no coming back from a bad start. The entire foundation of a good recording depends on getting this first step perfectly right.
Okay, so how do we get it right? Well, we start with a map. And what's great is that every single skull, no matter the shape or size, has 4 fixed anatomical points. Think of them as unmovable landmarks, the skull's own true north, south, east, and west.
Our first landmark, our true north, is the nasion. You can actually feel it on yourself right now. It's that little dip at the bridge of your nose, right there between your eyes. This is our starting line, the beginning of that critical front-to-back journey across the scalp.
And at the complete opposite end, we have the enion. This is that very distinct bony bump at the back of your head. Now, a really common mistake is confusing this with the soft crease of your neck or your hairline. Nope, you have to feel for the bone itself. That's our true south, and it's the finish line for that first measurement.
So next up, we need our east and west points. These are called the preauricular points. You'll find them in those little indentations right in front of your ears. A neat trick is to open and close your jaw a little. You can feel the hinge move right there. These 2 spots are the anchors for our side-to-side measurement.
All right, we found our 4 landmarks. The map is laid out. Now, the real journey can begin. We're about to chart the head's blueprint by following 2 main paths across the scalp, using those unmovable points to guide us.
First up, the most critical path, the nasion to enion measurement. You're going to place the end of your tape measure right on the nasion, run it in a perfectly straight line over the very top of the head, and end it precisely on that bony bump, the enion. Make sure the tape is snug, not loose, but not pulling tight either. Then you write down that total distance.
So, this is where that funny name, the 10-20 system, actually comes from. It's not random. That total distance you just measured is broken down by percentages. We mark a point at 10% from the nasion, then another 20% from that, and another 20%. And look, right at the halfway point, exactly 50% of the total distance, that's our target, CZ. This is our first mark. But wait, we're not done yet. We have to confirm it. This is science, after all. So now we take our second path. You place the tape on the left preauricular point, run it straight over the top of the head, it'll cross that first line we made, and end it right on the right preauricular point. And again, you record that total distance. And here's the moment of truth. Just like before, we find the 50% mark of this new ear-to-ear measurement. Now, for this whole thing to be correct, this new mark must land on the exact same spot as the 50% mark from our first measurement. No exceptions. And that brings us to the moment of discovery, that point where our 2 paths, our 2 lines of measurement, intersect perfectly. It's not a guess, it's not an estimate, it's mathematical certainty. That is how you find CZ, the central zone.
So let's recap. You've now made a mark from that front-to-back line.
And then you made a second one from the side-to-side line. These aren't suggestions, they are confirmations of each other. They absolutely have to land on the exact same spot. Literally, X marks the spot.
So what happens if they don't match up? What if they're a millimeter off? This is where real discipline comes in. The rule is simple, and it is absolute. If they do not match, you remeasure. You do not average the 2 spots, you don't pick the one that looks better, and you certainly do not guess. You go back to your landmarks and you measure again until they align perfectly, period.
You might be thinking, man, that is a lot of work for one single point on the head. And you're right, but here's why it matters so much. C as isn't just another location, it is the central anchor point. It's the keystone from which almost all other electrode positions are going to be measured and placed. If your CS is wrong, the entire map of the brain that you're about to create will be totally skewed. Getting this one point right it's literally everything.
Okay, so what is the big payoff for all this meticulous, careful work? Well, it's simple. This level of precision is what turns a physical measurement on a head into clear, reliable, and truly meaningful data about the brain.
Let's make this super concrete. Take sleep studies, for example. The cost of being just a little bit off is huge. An incorrect C placement, you might get poor visibility of sleep spindles, which are critical for figuring out sleep stages. A little bit of asymmetry from a bad setup, you could completely miss brain arousals. All of this leads to incorrect sleep scoring, which can seriously affect a patient's diagnosis and their treatment.
But when you do it right, that's when everything just clicks. Your results become reproducible time and time again. Your data is now comparable to other studies around the world. Your findings are scientifically defensible. And most importantly, for patients, it means diagnoses are accurate. This is the bedrock of good science.
So, if you take just one thing away from all of this, let it be this. The brain is telling this incredibly complex and subtle story through its electrical waves. But that amazing story, all that incredible information, can only be read accurately if the map we use to listen is drawn perfectly, right from the very start.
And that kind of leaves us with a final thought, doesn't it? We have just spent all this time focused on the painstaking, meticulous process of finding just one single point. So, if one point requires this much precision, just imagine what it takes to accurately map the entire brain.